A ball of mass 0.15 kilogram is dropped from a height 10 meter, strikes the ground and rebound to the same height. The magnitude of impulse imparted to the ball is nearly. G can be taken as 10 meter per second square. Options are given. 1.4 kilogram meter per second, 0 kilogram meter per second, 4.2 kilogram meter per second, 2.1 kilogram meter per second. This is a question from NEET 2021. See, first of all, we have to understand the situation. See, assume that you have a floor here, and to the floor, a ball is falling from a height h. See, this height is h. Now, when a ball falls, free falls, if free fall is happening, just before hitting the ground, we can find out the velocity. How to find out that? Using the kinematic equation. We can use the equation v square is equal to u square plus 2as. So, in this case, u square, u is equal to 0, initial velocity 0. So, v square is equal to 0. 2, how much is a? Minus of g. G is acting in the minus y direction, downward direction. And displacement, how much is that? Minus h, because I am choosing this point as origin. So, motion is in the negative y direction. And you can easily say that v square is equal to 2gh. Negative, negative will get cancelled out. And we can write on v is equal to under root 2gh. How much is g? 10. How much is h? 10. We can say this is equal to root of 2 into 10 multiplied by 10, root of 200, or 10 root 2. Velocity at which the ball hits the ground is 10 root 2. So, we can say velocity is equal to 10 root 2 meter per second. Now, if it is perfectly elastic collision, what do you mean by elastic collision? See, to the surface, on the surface, if the ball is hitting, if it is perfectly elastic, that means ball hits here. If it is perfectly elastic, we can say coefficient of restitution is 1. There is no loss of energy. So, ball goes in the upward direction after rebounding here with same velocity. So, we can say previously the velocity was, in the downward direction. So, when velocity was in the downward direction is in the minus y direction, or we can write down velocity initial is equal to minus of 10 root 2 j cap, because it's in the minus y direction. If it is rebounding with same velocity, we can say that the final velocity is equal to v final is equal to plus 10 root 2 j cap. Fine. We have initial and final velocity. Fine. How to find out the momentum? Momentum is nothing but mass multiplied by velocity. We can find out initial momentum. Initial momentum is equal to mass of the ball multiplied by v initial. And we can find out final momentum, which is equal to mass multiplied by v final. See, we can find out the change in momentum. Change in momentum is nothing but what is change in momentum? Delta P. Delta P is equal to P final minus P initial. In our case, we can take mass common, V final minus V initial. How much is the value for V final? You already know that. Mass multiplied by, so change in momentum is equal to mass multiplied by V final. 10 root 2 J cap minus of, what is V initial? Minus of 10 root 2 J cap. Fine. Negative, negative will add up together. So, how much will be the value? 2 times 10 root 2 will be there. Fine. So, delta P is equal to, change in momentum is equal to mass multiplied by 2 times 10 root 2 is the change in momentum. Now, how much is this value? Mass is given as 0.15 multiplied by 2 multiplied by 10 multiplied by root 2. How much is this? 0.15 into 2, 0.3. 0.3 into 10, 3. So, this is 3 multiplied by root 2. How much is root 2? 1.414. All of you should keep that value in mind. It's very useful. 3 multiplied by 1.414. So when you are multiplying 3 into 1.414, how much you will get? You will finally get 4.242. This is the final answer. This much kilogram meter per second is the change in momentum. Kilogram meter per second. Now, what is the logic? In the question they are asking the impulse. What is impulse? As per second law, the force acting on a body is equal to dp by dt, rate of change of momentum. So when you are multiplying force multiplied by dt, this is going to give you change in momentum. Fine. See, what is F into dt? F into dt is nothing but impulse, a very huge force acting for a short period of time. So that is known as impulse. This quantity is usually represented by the letter I in physics. So F into dt. This is exactly what we need in the problem. And we already found out that, how much is the change in momentum? 4.242. That is the correct answer. Let us see the option. 4.3. This is the right answer. 4.2. Option 3 is the right answer. 4.2 kilogram meter per second. I hope all of you understood this problem.